Okay, so then on numbers 12, it looks like through 16, they're asking the same type of question. So we'll start with number 12, and it says, what is true about the lines represented by the system of equations? So for all of these, the first step is going to be to write them in slope-intercept form, which is y equals mx plus b. So the first one, I have 3y is equal to negative 2x plus 6. To get y by itself, we divide each term by 3. And I get y is equal to negative 2/3 x plus 2. I'm going to check the second equation and do the same thing, which I have negative 6y is equal to 4x minus 12. Divide by negative 6. And I get y is equal to, I'm going to reduce this, so it actually becomes negative 2/3 x plus 2 in slope-intercept form. And as you can see, these equations are exactly the same. So they have the same slope and y-intercept. So these lines coincide. That means they're the exact same line, so it's going to be C as your answer for 12. So for number 13, we're going to do the same thing. We're going to write them both in slope-intercept form. So looking at the first equation, I have 2x minus 6y is equal to negative 10. To get y by itself, we subtract 2x. I have negative 6y is equal to negative 2x minus 10. I'm going to divide all three terms by negative 6, and I get y is equal to 1/3 x plus, it looks like 5/3. And then I'm going to check the next one, and it has negative 10x plus 30y is equal to 30. And so then I'm going to add first over the 10x. To get it in slope-intercept form, again, that's the goal. So I have 30y is equal to 10x minus 30, plus 30. Divide both sides, all three terms by 30. And I get y is equal to 1/3 x plus 1. Okay, if you compare your two equations, they have the same slope but different y-intercepts. And if they have the same slope and different y-intercepts, these lines are considered to be parallel. So B should be the correct answer. So on 14, they're actually both written already in slope-intercept form for you. And what I want you guys to notice is on the second one, they use a decimal, but really that just means 1/2 x plus 3. So looking at your slopes here, you have negative 2 and a positive 1/2. Those are considered opposite reciprocals. Sorry, they're not equal. They're opposite reciprocals, so that means negative 2/1, opposite sign is positive, and then flipped is 1/2. So if they're opposite reciprocals, they're actually considered perpendicular. And so the one that says that they are perpendicular is going to be A. So now we're on, it looks like number 15. I'm going to write them both first in slope-intercept form again. So I have 4x minus 8y is equal to 12. On the next one, I have negative 4x plus y is equal to negative 5. Over here on the left one, I'm going to subtract 4x, and then I'm going to end up dividing by negative 8. So I have negative 4x so far plus 12. Divide by negative 8 on all three terms, and I get y is equal to positive 1/2 x minus, it looks like it's going to be 3/2, because 4 goes into both 12 and 8. On the next one, I just need to add 4x, and y is equal to 4x minus 5. So comparing our two equations, they do not have the same slope, and they don't have opposite reciprocal slopes. So the knowledge that I have now is that these equations will intersect, but they're not perpendicular since their slopes, again, are not opposite reciprocal. So the answer that says that is going to be A. On 16, it's actually really easy. They're both already in slope-intercept form for you again. And if you compare your slopes, you have the exact same slope, different y-intercepts, so they're not coinciding because they'd have to be exactly the same. With just the same slope, then you actually know that they're parallel. So your answer should be B for 16. Okay, so then for numbers, it looks like 17 through 20, they're kind of asking the same type of question. So I'll do those all together. On number 17, it says the sixth in the linear function, negative 3x plus 6y is 2, is changed to negative 2. How will the new graph compare to the graph of the given function? So I'm going to look through my responses, and they're all talking about slope. So I'm going to write that one in slope-intercept form so I can identify what the slope is, and then I'm going to change it with a 6 instead, or sorry, with the -2 for the 6 instead, and then compare what my slopes are, what happened with them. So again, the first one, I have -3x plus 6y is 2, and then the second one is the -3x, looks like minus 2y is 2. So looking at these, I'm going to first add 3x, and I get 6y is equal to 3x plus 2, divide by 6, and it looks like my slope is positive 1/2. And then I'm going to look at the other one. When I change that 6 to a -2, I'm going to add 3x, and I have -2y is equal to 3x plus 2. I'm going to divide by -2, and I get y is equal to 3 over 2, sorry, it's negative, x minus 1. So it looks like our slopes are, it's now negative, and our y-intercepts also change. So looking through our options, A says the slope would change from positive to negative, and the y-intercept would stay the same. Well, we know that's not true. The y-intercept changed. The next one says the slope would change from negative to positive. Well, it changed from positive to negative, so it can't be that option. And then C says the slope would change from positive to negative, and the y-intercept would change. And that's exactly what happened, so that answer is C for 17. So the next one says the -4 in the linear function 6x plus 2y is equal to -4 is changed to 3. How will the new graph compare to the graph of the given function? So they're talking about slope in our responses as well as the y-intercept. So I'm still going to write it in slope-intercept form with both changes since I can see both the slope and the intercept from that. So the first one would be 6x plus 2y is equal to -4, and then the -4 is changed to a 3. So 6x plus 2y is 3. So then on this one, subtract 6x. So I have 2y is equal to -6x minus 4. Divide each term, and I get y is equal to -3x minus 2. On this one on the right, I'm going to do the same thing first, subtract 6x, and then I have 2y is equal to -6x plus 3, divide by 2, and y is equal to -3x plus 3 over 2. So comparing my two equations, it looks like the y-intercept is the only thing that changed, and it looks like it changed from -2 to 3 over 2, which is the same as 1.5. So the option that states that is B. It says the y-intercept would change from 0, -2, because again this is the y-intercept, to 0, 1.5. Okay, so now on number 19 it says the 3 in the linear function y is equal to 3x plus 6 is changed to 1/3. So these are already actually written in slope-intercept form for you. So you have y is equal to 3x plus 6, or y is equal to 1/3 x plus 6. So looking at our option, I'm going to rule out A and D immediately, since it says line becomes vertical, the line becomes horizontal. Those are special cases, and it's only if x is equal to a number or if y is equal to a number. So then I'm going to compare B and C. B says the line becomes steeper, but does not become vertical. C says the line becomes less steep, but does not become horizontal. Okay, so on a graph, if I went up 3 over 1, up 3 over 1, that would be the line. On this one, if I went up 1 over 3, up 1 over 3, this would be the line. So it's actually becoming less steep, so the one that says that would be C. So the last one on this page, 20, it says the 0 in the linear function y is equal to 3x plus 0 is changed to a 6. How will the new graph compare to the graph of the given function? So the plus 0 is the y-intercept. So the y-intercept is what's changing, and the only one that even talks about a y-intercept is C. So the y-intercept is going to change to 0 because the x value is 0, and then the y value would be 6.